AB.
And if it's adjacent, can it also be AB?
AB adjacent will be AD and BC also.
Okay, ma'am. Got it.
Okay. You can see here I have written AB, AB, BC, BC, CD, CD, DA, and DA, AB are the four pairs of consecutive sides. Okay. These are the four pair of your consecutive side. And the definition also you can see here the sides of a quadrilateral which have a common endpoint that is intersect each other are called consecutive sides. Okay. Now opposite angles, obviously the angles opposite to each other, facing opposite to each other. Okay. Two angles of a quadrilateral are said to be opposite angle if they do not have a common arm. Okay. For your definition purpose. Okay. Now this angle, we all know that this angle will be opposite to this, but in definition form, you can say there will be no common arm. The arms that when you are making an angle, so there are two arms that are required to make an angle. Okay, so they don't have any common arm, then the angles are opposite. Okay, now you can say angle A, angle C. Now this I have written for this particular figure. Okay, understood? Angle A, angle C are opposite to each other, and angle B, angle D are opposite to each other. So these are the two pair of opposite angles. Okay, because quadrilateral is a four-sided figure, so we'll be having four angles. Okay, understood? Now
Good evening,
consecutive.
ma'am.
Good evening, Nazir. Okay, we have just started the quadrilateral, just introduction. Okay, so consecutive or adjacent
Okay,
angles.
ma'am.
What are consecutive and adjacent angles? Okay, consecutive or adjacent is the same. You can say consecutive means one after another. Okay, so two angles of a quadrilateral are said to be consecutive or adjacent if they have a common arm. Okay, for example, in this figure, if you see, so angle A, if you are talking about consecutive angle of angle A, then it is angle D and angle B also. Okay, because these two angles have a common arm with angle A. Okay, angle A, angle B, angle B, angle C, angle D, and angle D, angle A are the four pairs of consecutive angles. Okay, in one order we are moving. Okay, now diagonals. Okay, meet the opposite. When you are joining the opposite vertex, then we call that line as a diagonal. Okay, in a quadrilateral, the line segment joining the opposite vertices is called a diagonal of the quadrilateral. Okay, in the parallel in the quadrilateral ABCD, AC and BD are two diagonals. Okay. Now the angle sum property of a quadrilateral. Now what does this angle sum property of a quadrilateral say? Then when you are going to add the angles, okay, there are four angles of the quadrilateral. When you are going to add the four angles of the quadrilateral, then the sum will be 360 degree. Okay, the sum of four angles of a quadrilateral is 360 degree. Okay, I'm going to highlight this. Now this you have to remember. Okay, that the from, like when you are proving, then you always write from the angle sum property. Wherever you have to show that angle A plus angle B plus angle C angle D is equal to 360 degree of a quadrilateral, then in the bracket you are going to mention from angle sum property. Okay, now if we are going, let's see the proof here. Now this is your quadrilateral. Okay, A, B, C, D. Okay. Now if we are going to join this, okay, we are going to join this. Just a minute. Okay, so we are going to join AC. Okay, and after that, when you're joining AC, you can see there are two triangles. Okay, one triangle this and one triangle this. Okay, and we know from the angle sum property that the sum of the angles of a triangle is equal to 180 degree. Yes or no? Okay, so from in triangle chapter we have already studied the angle sum property. So here angle BAC plus angle A, just a minute. Angle ABC plus angle BCA is equal to 180 degree. Okay, from the angle sum property of the triangles. Okay, so this is your for the first triangle. Okay, similarly for the second triangle, you can see from again same angle sum property of the triangle, angle DAC plus angle ADC plus angle DCA. DCA is equal to 180 degree. Okay. Now this is your first equation. This is your second equation. Now we are going to add up both the equation. Okay. adding equation first and equation second. Now if you're going to add, so LHS will be added on the LHS side and RHS will be added on the RHS side. So angle BAC plus angle ABC plus angle BCA plus angle DAC plus angle ADC plus angle DCA is equal to 180 degree plus 180 degree. Okay. So it will be your what? 360 degree here. 180 degree plus 180 degree, 360. Now, if you see angle BAC plus DAC. If you are going to see angle BAC plus angle D, this angle plus this angle is going to make angle A. Yes. So this angle I'm using one color. And this angle and this angle is going to make you angle A. Then plus. Now this angle and this angle will make you angle C. Okay. So BCA and DCA. This angle is going to make you angle C. Okay. And ABC will be angle B. Okay. Just a minute. This will be angle B and this will be angle C. Sorry, angle D. Okay. So angle A plus angle B plus angle C plus angle D will be equal to 360 degree. Okay. Okay. Now understood? Any doubt here? So from here we have seen that angles. Yeah,
No, ma'am, there's no doubt.
okay. So from the angle, now this is called what? Angle sum property. Angle sum property. Okay. So from this we know that the sum of the angles of the quadrilateral will give us 360 degree. Okay. Now just let's do a quick example on this. Okay. Okay. Can anybody will tell me that this exists or not? Can the angles 110 degree, 80 degree, and 70 degree and 95 degree be the angles of a quadrilateral? Can this be an angle of a quadrilateral or not? No. Why, Arham?
Oh my, I'm just waiting.
You're correct.
Ma'am,
They cannot make a quadrilateral because ma'am, by adding all these four angles, ma'am, I'm getting 355 degree. Ma'am, that is like less than 360 degree.
Yes, very good, Razi. Because when you are going to add all these values, okay, so you are not getting 360 degree, okay. The value that you are getting after adding is 355 degree, which is not equal to 360 degree. Therefore, it is not a quadrilateral, okay, because the sum of the angles of the quadrilateral is equal to 360 degree. Okay, now let's solve one more. Now let's see this question. Okay. Okay, now here a quadrilateral ABCD, angle A plus angle C is equal to 140 degree. Now here what is given? You see angle A plus angle C is equal to 140 degree. First of all, you can write it given. Angle A plus angle C is equal to 140 degree. Okay. And the ratio is also given. Angle A is to angle C is equal to 1:3. Okay. And angle B is to angle D ratio is also given, B plus C. Okay. So from these two equations, from these two values, you can find out. Okay. You can take it as for second. Okay. So you can, I have already explained you that whenever ratios are given, okay, so they are not the exact value. Okay. So we always multiply with a constant value K. Okay. And then, so angle A can be taken as 1K and angle B, angle C. Right? Okay. So angle C can be taken as 3K. Okay. So from this given angle A plus angle B is equal to 140 degree. That means K plus 3K is equal to 140 degree. Okay. So which implies that 4K is equal to 140 degree. So K value is what? 140 degree divided by 4. Okay. Echo is there, na? Aram, can you switch off the mic?
Okay.
No, actually, I think echo is there. Okay. Now, if you divide it, so you'll get 35 degree. Okay. So X value, the K value is equal to 35 degree. Okay. Now, from here, we get that angle A is equal to 35 degree and angle C is equal to 3 into 35. Okay. That is 105. Okay. Okay. Now, angle B and angle D ratios are also given. Okay. Yes. Now, similarly, we can find the value of angle B and angle D also. Okay. From as it is a quadrilateral. So angle B, angle A plus angle C plus angle B plus angle D is equal to 360 degree. Okay, and angle A plus angle C value is already given, that is 140 degree. Okay, so we plus angle B plus angle D is equal to 360 degree. Okay, so therefore, which implies that angle B plus angle D value will be what? It is equal to 360 degree minus 140. Okay, so which will be equal to 220 degree. Okay, 220. Okay, now B and D ratios are also given, 5:6, 5:6. So we can take it as 5x, 5k in fact you take, or k already we have taken, let it be x. 5x plus 6x is equal to 220 degree. Okay, so 11x is equal to 220, x is equal to 20 degree. Okay, x is equal to 20 degree. So therefore angle B is equal to what? 5x. So it will be 100 degree, and angle D will be equal to how much? 6x. Okay, so 120 degree. Okay, understood? Any doubt? In fact, you can add up all
No, ma'am, no doubt.
angle A, angle B, angle C, and angle D, and you can check that it will be equal to 360. Okay, so this was about angle sum property of the quadrilateral. Okay, now various types of quadrilateral. There are various types of quadrilateral. Okay, now what are these different types of quadrilateral? The first one is your trapezium. Now what is a trapezium? A trapezium, a quadrilateral in which one pair of opposite sides are parallel. Okay, only one pair are parallel. Okay, is called a parallel trapezium. Okay, now here you can see the diagram ABCD. Now one pair is parallel, that is DC is parallel to AB. Okay, this is a trapezium. If two non, and yeah, this is a note, if two non-parallel sides of a trapezium are equal, then it is called a isosceles trapezium. Okay, the non-parallel, that means AD and CD. If AD is equal to CD, then it is a isosceles trapezium. Okay, now parallelogram. So in parallelogram and in trapezium, the difference is that in parallelogram you have opposite sides, two pair of opposite sides are there, yes, and they both are parallel. Okay, a quadrilateral in which both pair of opposite sides are parallel is called a parallelogram. Okay, if both the opposite sides are parallel, then it is a parallelogram. Only one pair are parallel, then it is a trapezium. Okay, so that means from this what we conclude, that all parallelogram are trapezium. Yes or no? All parallelogram can be treated as a trapezium, because in trapezium one pair has to be parallel, but it is not said that the second pair cannot be parallel. Okay, so here I mentioned, yeah. So in parallelogram, a parallelogram is a trapezium, but a trapezium is not a parallelogram. Why? Because in parallelogram two pairs should be parallel. Okay, two pair of opposite sides should be parallel. Okay, so in the trapezium only one pair of opposite side. I have explained it here. The sum of the adjacent angle of a parallelogram is 180 degree. Okay, the sum of adjacent angles. Okay, one after another angle is 180 degree. Okay, that means this angle plus this angle is equal to 180 degree. In fact, if you remember when we were studying lines and angles, then I told you the two lines, if two lines are parallel and a transverse is crossing it, then the angles on the same side, the sum of the angles on the same side is 180 degree. Do you remember?
Yes, ma'am. And then if you add another line,
Yes,
it will
ma'am.
just, ma'am, if
Ma'am,
you add another
co-interior
line, it
angle.
will just
Yeah,
come the same
so
place.
here also same thing is there. See, DC is parallel to AB, and AD you can take it as a
Ma'am,
transversal. Yes, Razi?
ma'am, it is known as co-interior angle.
Yeah, Razi?
Ma'am, is it known as co-interior angle?
Co-interior angles. Yes.
Ma'am, was it supplementary angle?
No, this is your corresponding angles. This is your alternate interior angle. Co-interior angles are your this one, na? No, co-interior angle is your just line. See, alternate corresponding मैंने आपको लिखा दिया. Co-interior angle. See, angle 4 and angle 5. Okay. Angle 4, angle 5, and angle 3 and angle 6. Yeah, correct, Raj. It is co-interior angle. Okay.
Okay, ma'am.
This is your, this and this same side co-interior. This is your corresponding angles, and alternate angles you already know, the opposite one. Okay. So from there only you can see AB and DC. It is parallel. Both are parallel or not? Yes, both are parallel. And AD you can treat it as a transversal. Okay, so therefore angle A and angle D will be the sum of angle A and angle D will be 180. Similarly for all the angles. Okay, for B for B angle B and angle D, sum will be your 180 degree. Angle D and angle C will be 180 degree. Okay, because you have all the four side means opposite angles are opposite sides are parallel. Okay. Now sum of adjacent angles of a parallelogram is 180 degree. Okay. Now rhombus. Okay. What is it? Rhombus. Okay. Uh, a rhombus is this type of figure. Okay. Many times the kite, not exactly kite. Okay. If in the rhombus,
Ma'am, it's like all of the sides should be equal. I mean, like
yes, all
not
the
all of the sides, like the opposite sides.
no, not opposite. All the sides are equal. Like in the square, na rhombus is same means you can say that all the squares are rhombus, but all the rhombus cannot be square. Okay, why? Because rhombus all the sides are equal, and square also all the sides are equal. But in
Ma'am,
square the angle is 90 degree.
yes, ma'am.
Okay, but in
Ma'am,
rhombus angle is not
ma'am,
90.
square is like all of them.
Square is like
All of them.
all of
them.
them.
And because they have like the sides are parallel, so it's a trapezium and a parallelogram, and it's also rhombus.
Yeah, see, squares, all the sides are equal. The sides are parallel also, and it is 90 perpendicular. In fact, they are perpendicular to each. All the sides are perpendicular to each other. Okay, the angle made here is 90 degree in the square. Okay, all the sides are this side is perpendicular to this one. This side is perpendicular to this one. All the angles are here 90 degree, and all the sides are equal. Okay, but in rhombus all the sides are equal, but angle is not 90 degree. Okay, they're not perpendicular. Here it is parallel. Okay, in the above figure, see here it is written AB is parallel to DC and BC is also parallel to AD. Opposite sides are parallel and sides are also equal. Okay, so you can say here that all the rhombus can be a parallelogram, but all the parallelogram cannot be rhombus. Okay, because here also opposite sides are parallel, but here all the sides are equal. But in parallelogram, we cannot say that all the sides are equal. Okay.
Okay.
Now, rectangle. A parallelogram in which one of its angle is right angle is called a rectangle. In other words, so here also what is a rectangle? All the sides are not equal. Opposite sides are equal. Okay, and the angle they are perpendicular to each other. Okay, not only one. All the angles here are 90 degree. Okay, all the angles are here 90 degree, and AD is equal to BC and AB is equal to DC. Okay, and opposite sides are obviously parallel also. Okay, ABCD is a rectangle. AB is parallel to DC and AD is parallel to BC. Okay, and it is equal also, and your angle are also 90 degree. All the angles are equal to 90 degree. Okay, angle, it is written here in definition that only one angle is 90 degree. So from here only, if one angle is also 90 degree, angle A, so angle D and angle A will be equal to 180 degree. Okay, corresponding co-interior angles. Okay, so co-interior angles 90 degree. So this 90 degree 180 degree, so it will angle D will also become 90 degree. If you find out from 190 plus x is equal to 180 degree, so therefore value of angle D will also be 90 degrees. Similarly, with D and C will again be co-interior angles, so angle C will also be equal to 90 degree. Angle C and angle B will be co-interior, or angle A or angle B will be co-interior. So all the angles are here 90 degree. Okay, any doubt?
No, ma'am, no doubts.
Okay, now similarly in square, here also all the opposite sides are parallel and all the sides are equal and all the angles are also equal to 90 degree. Okay, now important facts that all square is a rectangle and rhombus also. All the squares are rhombus also and rectangle also. Okay, because in rectangle opposite sides are equal, but if all the sides are equal, that can be also treated as a rectangle. Yeah, it is a special type of square, but it can be a rectangle category also. Okay, if that sides are equal. Okay, and it is a rhombus also. a rectangle or a rhombus is not a square, obviously, because rectangle opposite sides are equal, so it cannot be treated as a square, because in square all the sides should be equal. Okay, now the sixth one is the kite. Okay, you have seen kites. Okay, in kites what happened, your adjacent sides are equal. Okay, not the opposite one, or not all the side, adjacent sides are equal. Now here, and then if you see A is the common vertex. Okay, so that means AB and AD sides are equal. Okay, so C is the common vertex, so BC and DC are equal. Okay, a quadrilateral in which two pair of adjacent sides are equal is known as a kite. Okay, a kite is not a parallelogram. Why kite is not?
Ma'am,
Yes, Nazi?
ma'am, can we consider diamond shape also a quadrilateral?
Yeah, in fact, the diamond shape is like a kite only. Yes, now this is also a diamond.
Yes, ma'am.
Okay, see, diamond shape. See, a rhombus can also be, you can say, a diamond one. Okay, but generally diamond shape will be the kite one. Okay, so kite or diamond you can say, but this kite is not a parallelogram. Okay, because in parallelogram opposite sides are parallel. Okay, but here opposite sides are not parallel. Okay, so kite is not a parallelogram.
Okay, ma'am.
Now let's see some example. Any more doubt, anybody, in all the types of your quadrilateral, in parallelogram or trapezium, square, rectangle, rhombus, kite? Any doubt in any one of that?
No, ma'am.
Okay, let's see a question. Okay, all the angles of a quadrilateral equal. What special name is given to this quadrilateral? If all the angles of a quadrilateral are equal, then which type of a quadrilateral?
Ma'am, square. Ma'am, square.
Only square, Razi? It is not talking about the side, it is talking about angle.
Ma'am, rectangle also.
Yes, because in both this, all the angles are equal to 90 degree. If it was talking about the side, then square is there, okay, and rhombus is also there. But if it is talking about sides and angle both, then only square is there. But here it was talking about only angles, so square and rectangle both will be there. Okay, now some important results. Okay, now results means your conclusion that we have seen here, that every square, rectangle, and rhombus is a parallelogram. Why? Because in all the three, you can see that opposite sides are parallel. Yes, opposite sides were parallel in square also, opposite sides were parallel in rectangle also, opposite sides were parallel in rhombus also. Therefore, all these three are parallelogram also. Okay, now every square is a rectangle as well as rhombus. We have seen that also. Why? Because rhombus means what? All the sides are equal, and in a square all the sides are equal. Yes, and one additional property is there for square, other than rhombus means additional property what is added in square, that all the angles are 90 degree. Okay, which is not possible in your rhombus. Not possible, you cannot say, which is not there, this property is not there in rhombus. Okay, so that's why square can be a rhombus, but rhombus cannot be a square. Okay, rectangle also, square can be a rectangle, but rectangle cannot be a square. Okay, a kite is not a parallelogram. We have seen why, because opposite sides are not parallel. Parallelogram, in parallelogram opposite side should be parallel. Okay, in trapezium only one opposite pair are parallel, so it is not a parallelogram. Okay, but parallelogram can be trapezium. Every rectangle or rhombus is not a square. All the rectangle or rhombus is not a square. Every means obviously rectangle and rhombus cannot be square, because in square all the sides should be equal, and at the same time all the angles should also be equal to 90 degree. Okay, the diagonals of a rectangle bisect each other and are of equal length. Okay, bisect means all the where it is written here, the diagonals of a rectangle bisect each other. Okay, they bisect each other, every is equal, and they are of equal length also. The diagonals are of equal length. Similarly, the diagonals of a rhombus bisect each other at right angle. Okay, they bisect each other at right angle. This angle is equal to 90 degree. Okay. The diagonals of a square bisect each other at right angle and are of equal length. Same thing, the square also. If you have drawn a square and you are drawing a diagonals, okay, so they are of equal length and it is bisecting at, if they bisect each other at 90 degree, means both the angles is 90 degree. Okay, all the angles here also is 90 degree. Okay, angle opposite to equal sides of a triangle are also equal. Okay, we already know that if this side is equal to this side, the angle opposite to them also is equal. And this type of triangle is called what is the name of this type of triangles? Isosceles triangle. And what is the quality of isosceles triangle? The two sides that are two sides are equal, isosceles triangle, and the angle opposite to these two sides are also equal to each other. Okay, that is said in this. Diagonals of a kite bisect each other at right angles. Okay, diagonals of the kite also bisect each other at 90 degree. Okay, these all are 90 degree. Understood? Any of the point? Anybody has any doubt in any one of the points? No? Okay. This was just the introduction of your quadrilateral. Now we are going to study one of the quadrilateral, that is parallelogram, and we'll see the properties of a parallelogram. Okay, what are the properties of a parallelogram? So what we have seen, what is a parallelogram? It is a four-sided figure where the opposite sides are parallel to each other. Okay, now theorem 1. Okay, we'll be covering 6 theorems here. I think, no, not 6. There are a total of 8 theorems. Okay, and based on these 8 theorems, we will be solving numericals. Okay, the questions. Okay, geometrical questions. Okay, now, and whenever it is about theorem, so you have to remember the theorem by heart. Okay, we will be seeing the theorem, that how it is proved or why it is so. Okay, but you should remember the theorem statements. Okay, so theorem 1, a diagonal of a parallelogram divides it into two congruent triangles. Okay, so let's prove that lines are parallel. Okay, I'm naming same A, B, C, D. Okay. Now we have to prove that the diagonal of the parallelogram, that means AC, is going to divide it into two congruent triangles. Okay, so if we are talking about congruent triangles, so how we can prove for congruent triangles? Anybody can tell that how can we prove that the two triangles are congruent?
Ma'am,
How many rules are there to prove a triangle congruent?
tell.
Yes, tell Anna.
Side, angle, side angle, and side angle side.
SSS, ASA, in fact AAS also you can use. RHS is also there. Okay.
Oh yeah, RHS.
Okay, and SSA is there.
SSA is also there.
No,
Side.
SAS, SAS.
This one there.
Okay.
And ma'am, we can say that AC is like so we can say that AC is the same by knowing that. Ma'am, we can say diagonal.
Ma'am,
We know.
ma'am, in both triangles, ma'am, AC is equals to AC because it is common.
AC is equal to AC because it's the same. And
Yeah,
angle, some angle angle what is it? CAB, we know is equal to angle, what is that one? Angle, is it DCB? Because of because what is that pair of angles called? Alternate
angles.
So that's, and then we know, and then we can say the side is equal to that other side on top, AB, is equal to DC because they are parallel.
Okay, very good. Okay.
So you can.
Okay, if you see here, BC, this BC is parallel to your AD. Okay. Yes, and AC you can say it as a transversal. Okay, so if AC is a transversal, so BAC, this one, BAC will be equal to this angle. Why? Because of alternate angles. Okay, alternate the pair of alternate angles are equal when the lines are parallel and a transverse is crossing it. Okay, similarly, this angle is equal to this angle. Again, how? Because DC is parallel to AB and a transverse is crossing it. Okay, AC is crossing it. Okay, so these two angles are equal. Okay, and AC is common. Yes, so therefore the triangles are congruent from which rule? ASA rule. Okay, angle, side, angle. Okay, ASA rule.
No, ma'am, SAS. Ma'am, because we first did AAC, then angle CAB, and then AB. So it's SAS.
Arham, we are not taking two sides. See, we are taking SAS means, see, SAS means two sides should be there, and the two sides that you're taking the angle between that, but we are taking two angles and one side. We are taking two
We
angles
took
and
we took AC and AB, right?
you are taking this one blue this angle and this angle and this common side you are taking. So दो angle के बीच वाला side आप ले रहे हो ना. So ASA.
Oh God.
Yes. So from ASA, both the triangles are congruent. Any doubt in this? Okay. So see, I have written with all the details. Okay. That AC is common, everybody know. And how angle BCA is equal to angle DCA. Okay. Transversal, so pair of alternate angles are equal. Okay. Similarly for BAC and DAC. Okay. So triangles are congruent from ASA. Okay. So we have proved here theorem 1. Okay. Theorem 1 says what? That a diagonal of a parallelogram divides it into two congruent triangles. Okay. Now, this theorem 2, in a parallelogram, opposite sides are equal. Okay. Now, how can you prove that opposite sides are equal in a parallelogram? Anybody can tell? It is saying that this should be equal to this and this should be equal to this. Opposite sides are equal. I'll name them, say A, D. Okay, so we have to prove that opposite sides are equal to each other. Now here again, what we are going to do, we are going to do some construction work. That is, we are going to join AD. Okay, so if we are joining AD, so we already know that the triangles are congruent from the first theorem. That first theorem says what? That in a parallelogram, if we have got the diagonals divides the parallelogram into two congruent triangles. Okay, so from this theorem, triangle ABC is congruent to triangle CDCDA. Okay, okay. So therefore, AB is equal to DC from CPCT. Yes or no? Yes. And AD is equal to BC from CPCT. Yes. In fact, you can take another triangle also. Okay. Another triangle means this diagonal. You can take the another diagonal, this one. Okay, you can take this diagonal also, and from here also this triangle also. So triangle DAB is congruent to triangle DCB. Okay, so from here also you can say that AD is equal to BC from CPCT. Okay, because if the triangles are parallel, that means if the triangles are congruent, that means all the three angles will also be equal and all the three sides will also be equal. Okay, triangles means the triangles are congruent means they are going to overlap each other. Okay, and similarity means their size can vary. Okay, but they're similar type of triangle. If one is isosceles, the other one will also be isosceles. If one is scalar, the another one will also be scalar. Okay, just it is the size may differ, but in congruency means they're going to overlap each other. If you have proved that the two triangles are congruent, means all the three angles will also be equal and all the three sides will also be equal. Okay, but when we are proving that the triangles are congruent, it is not necessary that we should have all the three sides or all the three angles also. If all the three sides are given, then also you can prove. If two angles and the middle side is given, then also you can prove. If two side and the angle between them is given, like ASA, SAS and RHS. Okay, these are the four congruents. Okay, now any doubt till here? Okay, because time is also there, so we are ending here, and in the next class we will be covering the theorems. Okay, 3, 4, 5. Okay, all other theorems are there. Okay, you can go through in the handouts. I'll be uploading the handouts. Okay, so you can check there. Okay, Razi
Bye, ma'am. Thank you.
and Amulya, about.
No, ma'am.
Okay,
No,
so
ma'am.
we are ending the session here, and in the next class we'll see from after this. Okay, the other theorems. We'll be covering the other theorems, and after that we'll see the question based on that. Okay, bye bye till then.
Okay, ma'am. Bye, ma'am. Thank you, ma'am.